Okay, so I want to introduce some terminology. This is something that's going to become important in this class for you to understand. A neuron's going to carry messages, right? Electrical messages, and but it's not going to carry messages all the time, right? So we're talking about a certain level of charge difference, right? Inside versus the out in a neuron at rest. And a neuron at rest is not sending an electrical message. This is, basically a neuron that's quiescent, right? It's at the resting potential, which I suggested, because of the action of the pump, because of the permeability, aspects of the membrane, and because of the presence of all those anions on the inside of the cell versus the outside, is going to be at a particular value that we can measure, right? We can put an electrode inside, have an electrode outside, and we can record the difference in charge, distribution across this membrane. It's about, at rest, about minus 65 millivolts. It's more negative in here versus the outside. Now, that minus 65 millivolts represents a certain level of difference, right, in charge, inside versus the outside. It's a certain level of polarization. There's a polarization here. The inside is different than the outside. There's a certain level, and we measured it in millivolts, right, by putting electrodes in and out. We say that, there's the level of polarization, right, in a neuron at rest is minus 65 millivolts, okay? Now, it turns out that we can change that relationship, okay? The charge difference between the inside and the outside. And our ability to change that, or the neuron's ability to change that, is essential in determining when it will actually carry an electrical message, literally carry what we call the action potential, the movement of charged particles from one end of the neuron to the other. Okay? So a neuron at rest, minus 65 millivolts, more negative on the inside than outside. Okay? But if the inside were to become even more negative, okay? If you were to suddenly increase the difference in charge between the inside and the outside, right? You're increasing the polarization. You're making it even more negative. So you're going from, let's say, minus 65 millivolts at rest, right? It's a level of polarization. Let's say you make it more negative. You would measure it as minus 75, minus 80, right? If you make it more negative on the inside, you're increasing the level of polarization in terms of charge between the inside and the outside. This we call a neuron that has been hyperpolarized. So hyperpolarized means you're increasing the difference in charge between the inside and the outside. And let's think for a moment about how you could do that, okay? So if you have a neuron,